This is Block 2 of Topic 4. In this lesson, we're going to be looking at what are called the properties of equality. That's just a review from algebra. And learning two new postulates for geometry called the segment addition postulate and the angle addition postulate. We're also going to be looking at some geometric proofs. Last night on your homework, you looked at an algebraic proof, but today we're going to start looking at applying those proofs to geometry. And we're going to look at two different formats, the two-column format and the flowchart format. So think about if you were accused of doing something that you are absolutely innocent of. So you may have seen many court cases on a TV show or been involved in maybe one in real life. I don't know. But if you're trying to prove someone innocent, you have to provide a lot of details. You have to maybe provide an alibi or certain proof that shows that someone is innocent. So that's kind of like what a proof is in geometry. It's providing a lot of detail to prove that something is true. So it's a lot of detail, a lot of specific information in a proof of geometry. We're going to begin by looking at that homework problem I mentioned from last night. Remember, you had an equation and you had all the steps shown as your statements, and you had to justify each step of your algebra equation solving with a reason for each step being true. That's similar to what we're going to be doing with geometric proofs. We will have statements, and every statement we write will have a reason of why we know that to be true. Some of the reasons that we use are called algebraic properties, the properties of equality that you learned in algebra. So we're going to begin with an animation that will help us answer number 1 in our notes. The first one starts off with two segments, QR and ST, that are the same length. They are equal in length. What we are going to do is add a certain length to both segments. So we're adding BC to both segment QR and ST. So since QR and ST were equal, when we add the same thing to both of them, we're still maintaining that equality. And that property of equality is called the addition property of equality because that's what we're doing, adding the same thing to both sides. So part A of number 1 is the addition property. It's really the addition property of equality, but we typically just call it the addition property. The next slide we're looking at has two angles that are the same degree measure. So angle ABC and angle KMR are congruent, or in other words, their measures are equal. We have a property that says it doesn't matter the order that you write two things that are equal. So for example, in algebra, if you got a solution x equals 2 and your neighbor wrote down 2 equals x, they're both correct. They mean exactly the same thing. So same thing here. The measure of angle ABC equals the measure of angle KMR. It's exactly the same thing as saying the measure of angle KMR is equal to the measure of angle ABC. That is called the symmetric property. So you know what it means for two things to have symmetry, and that can be applied here. This is the symmetric property of equality. Just says the order you write two equal things does not matter. So if A equals B, then B equals A. That means exactly the same thing. The next property, we have a segment AX, and we're saying it equals itself. So kind of like when you look at yourself in the mirror, you're looking right back at yourself. And similarly, the name of this property is called the reflexive property. So that's your reflection in a mirror, and that's kind of what we're looking at here. Something is looking at itself, the reflexive property. That comes up a lot in proofs. You wouldn't think so, but it does. And so that just simply means A equals A. Something is equal to itself. The next property, we have three different angles, and we are told that the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3. So since both the measure of angle 1 and the measure of angle 3 are both equal to the measure of angle 2, then that means they are equal to each other. The measure of angle 1 is equal to the measure of angle 3. That is called the transitive property. So part D is transitive property. It states if A equals B and B equals C, then A equals C. Whoops, I wrote A and said C. All right, so the next one, we have two angles, angle 1 and angle 2, but it tells us that it takes 2 of the measure of angle 1 to equal 1 of the measure of angle 2. Well, that is the same thing as saying the measure of angle 1 is equal to the measure of angle 2 divided by 2. So we are essentially cutting each one of the sides of the equation in half. So that is the division property. We divided both sides by 2 is what we ended up doing. And so that is E on your notes, the division property of equality. Again, as long as you do the same thing to both sides of an equation, you're keeping it equal. So in algebra, when you solved equations like 2x equals 4 for x, you divided both sides by 2 using the division property of equality. The next one, we have a similar one to the drawing we had at the beginning, but this time we're taking away the same amount from both sides. So we had JK, let's go back to that, JK plus AB equal to RQ plus AB, and we took the AB away from both sides. So what property did we use? We used the subtraction property. We subtracted AB from both sides of the equation and kept it equal. So F on your notes is the subtraction property of equality, or just the subtraction property. On the back of your notes, our next drawing, we have AB plus BC, and we're told that BC and DE are the same thing. So that means AB plus DE would be the same as AB plus BC. So AB plus BC gives me the length of AC, and since these two things are equal, I can replace BC with DE. That's called the substitution property. When you replace something with something that is known to be equal to it, that is substitution. So G is the substitution property. So for example, in algebra, if you had an equation like 2x plus 3 equals 9, you would use the subtraction property of equality to subtract 3 from both sides, and then the division property of equality, dividing both sides by the same number, and we get x equals 3. Substitution would allow us to check our answer. Since x and 3 are equal, we can go to our original equation and replace x with 3. That's the substitution property, replacing something with something that is equal. So since B and C and DE are equal, we can replace one with the other. Our last property, it says if the measure of angle 1 is half of the measure of angle 2, then that means it takes 2 of the measure of angle 1 to equal 1 measure of angle 2. So we got rid of the 1/2, which is the same thing as dividing by 2, by multiplying by 2. So we know that those are inverse operations. On this one, we are multiplying both sides by the same number, so that's the multiplication property. I guess I should click on it here so you can see that. So in algebra, you used the multiplication property when you were given equations like x over 2 equals 5. To solve for x, you were undoing division by using multiplication and multiplying both sides by the same number. So as a result of that multiplication property, you were allowed to solve the equation for x. So those are our algebraic properties. They come up a lot in proofs. A lot of your reasons for some of your steps in proofs will be those algebraic properties. So you may want to keep this notes handy until you get really familiar with the names of those properties. That will be really important. Also, in our proofs, we will be using what are called postulates. So you have the definition of a postulate on number 2 in your notes. A postulate is simply a statement that we believe to be true, but we accept it to be true without a formal proof. So there's not a formal proof, step by step, that actually shows the statement to be true. It's just something that we believe to be true and accept it to be true without proof. Now, that may seem similar to what a word we've learned before, which was conjecture, but they are not the same thing. A conjecture is a statement that we believe to be true, but we don't accept it to be true. Okay, so it's a statement we made that we just think might be true based on our observations, but postulates are things that are believed to be true and accepted to be true. So that's the difference, the accepted part. Let's look at two important postulates that we're learning at today. So number 3 in your notes, we'll go over the first postulate. It says points A, Z, and B lie on segment AB. If A to Z, and remember no segment bar means that's a measurement, A to Z, that distance is 2 centimeters, and Z to B is 3 centimeters, then what is A to B? Well, this is using what is called the segment addition postulate. It just says that the parts have to add up to give me the whole thing. So since 2 plus 3 is 5, that means AB must be 5 centimeters. Now, since the drawing was here for me, that was very easy to see. If this drawing was not here, then this problem would not be as easy as it might seem to be as it was with the picture. Because we don't know for sure, if I don't have the picture, that Z is in between A and B. So, for instance, my drawing could have looked like this, with this being A, this being B, and this being Z. So now A to Z is 2, Z to B is 3. That doesn't make sense, does it? Okay, so it was an important assumption on our part to know that Z was between A and B for this to make sense, that these parts add up to be the whole. Okay, so without a picture, it might have been a little more difficult to solve the problem. But we're assuming Z is between A and B, and the parts must add up to be the whole. That, again, is called the segment addition postulate. And we'll look more at that in just a moment. All right, on number 4, I'll look at your notes here. A similar question, but it's dealing with angles this time. So given the angles as shown in the diagram, it says the measure of angle AXB is 15 degrees. AXB is this angle right here. I'll mark that as 15 degrees. BXD, the measure of it, is 20 degrees. BXD is 20 degrees. We want to know, what is the measure of angle AXD? AXD is the big angle. So very similar to what we did with the segment up here, the parts add up to be the whole. So we're wanting to know the whole, and so it is simply the sum of the two parts. 15 plus 20 is 35 degrees. Now again, the drawing was given to us. If the drawing was not given to us, then we would have to, in this situation, assume that point B is inside that angle AXD, as it is shown in this picture. So that, again, where it says on what assumptions are we basing our answer, we're basing it on the fact that we're assuming that point B is inside the angle AXD. That's an important assumption to make in order to use this angle addition postulate. So let's look at number 5 in our notes. And this will kind of sum up what we learned with these two postulates. So again, the addition postulates, segment and angle addition postulates, you'll hear me say a lot that the parts add to the whole. And that's what these two properties are saying, just that the parts are adding up to get the whole thing. So the segment addition postulate, if we know point Z is between points A and B, then we know that the parts, and our parts are A to Z, so you can put that in the first blank, and the other part is Z to B, and those parts must add up to get the whole thing, and the whole thing was the segment from A to B. Same thing with the angle addition postulate. We're assuming B is inside angle AXD, and again, the parts are adding to the whole. So these are my two parts I need to name. This is angle AXB. We're saying the measure of it because we're talking about a number here. The measure of angle AXB plus the measure of this angle, BXD, equals the whole thing, which is the measure of angle AXD. The parts add up to be the whole. And so, again, that creativity comes out in those mathematicians naming these postulates addition postulates. It makes sense. We're adding the parts to equal the whole.